Okay, so if you look at this graph, right? So you can see that our aim is, we want to first we have the plot of the graph, okay, and then we want to put in the red area, and we also want to find the probability between the lower limit and the upper limit. Okay, so that is our aim, right, for this example. Okay, so I think that we have, just now we also have plotted for the gamma. Okay, so for the gamma, right? Just now, so if we, as I said that, right, you have to change, well, you have to change the limit for your x-axis. So when you plot, okay, so said that we have, right, so this is the original one, which is the gamma 23. Okay, so if we use the example, right, so we have the same, well, you can just edit actually, right? You can just edit the command that is given in example 2 of your lab. Here, I think. Okay, oh, right. Okay, so actually what I did is just edit the lower limit. Well, you have to edit the function, of course, the gamma, right? Edit the limit, the range of your x. Okay, and then your lower limit, of course, is lower limit and upper limit is, in our example, we have 0.12, which is your percentile, your 5th percentile, and your 95 percentile, right? Okay, so as you see, right, we can actually use, because originally it's actually 0.118 and 0.158. Okay, so you can actually, well, because that one is for the sake of simplification, right? You can simplify 0.12 and 0.1558, or you can use the original, right? But for later on, when you want to find the probability, whatever, right, it's good to have at least like 3 or 4 decimal place. Okay, right. So anyway, so if it, it's not 1.56 or 1.58, let's see. Oh, okay. Right. Oh, okay. So it's approximately, it should be 1.58, I guess. Okay, right. Okay, so well, it's 558. We can change it 1.58. All right. So you can see over here, right? Change the gamma function, right? And you have the polygon, right? So it should be your hx for the upper limit and lower. This is the upper limit. Okay, and then you can see, right, that the area is actually the probability of x less than the upper limit minus the probability of x less than the lower limit, right? And that is the area, right? That is the area that under between the two limit. Yeah. Okay, and the probability, right? So if you run that, so yeah, okay. So if you run that, then you can see, right, that the probability is close to 0.9, right? And then you have your lower limit and your upper limit. Okay, so I mean, if you have your lower limit, upper limit, right? So you just need to change your lower limit, and you have to change the function of your gamma. And I think the area here, the axis here, I think you have to change this also a bit, because depending on the distribution, right? I think it will move a bit. I think I did a bit of edit to get this answer actually. Compared to the let me see, compare to example 3. Yeah, I think this axis is just a bit of yeah, I think I changed the axis. Okay, so you have to change, I think you have to change here the axis here to actually fit this graph. Okay, then only you can actually get the answer, right? But this one is playing around. So anyway, right, and if we have our HDR, which is your highest density region, so it should be 0.03, 1.28, 0.03, 0.03, 1.28, right? So that's why you need a parameter, right? So if you change the parameter, then everything will change, right? Then yeah, so you have here, right? So the area here actually you cannot see because it's actually close to 0. 0.03. Oh, sorry. Oh, because I actually double the 0.03. Okay. Wonder. 0.03. Okay, yeah. So there's a bit of area there. So you have 0.03 and 1.28. So yeah, this is close to 0.89. Well, this is the closest that we can get to 90% area under the curve, right? And you can look at the height here, right? So the height here should be, right? So if we look at the height, which is the d gamma, right? D gamma, which is at 0.03, and then this is 23, yeah, and 0.03 to 3, right? You see the height of the graph with the density is 0.246, and it's at 1.28 is, right? So it's not exactly the same, right? But it's approximately, right, to maybe to 2 decimal place, right? 0.25 and 0.25. Then you can see that the height of 0.03 and 1.28 is actually similar. Well, the best that we can do, right, at the 2 decimal place, okay, which is quite good because the height, you can see, right, the density is actually, the maximum is maybe around 1, I guess, around something. Okay, this is density. So you can see, right, the height here, 0.2 is here, 0.2. So the height of your x at your lower limit and the height of your graph at your upper limit is actually roughly the same. Okay, meaning that the density, the density or the height of the graph is going to be higher than the height of the graph outside of the red area. Okay, so that's why we can be sure that this is a HDR or a highest density region. Okay, but as I said before, this is like trial and error because we don't really know. You have to move, right? Meaning that you have to move your lower limit and upper limit, and you have to adjust it until you get like sort of the crossover there, and then the area here should be 1 minus alpha, which is your, in this case, alpha is 10, 0.1, 10%. Okay, so but you can see over here, right, this means the HDR, because your gamma is skewed, right, this gamma 23 is skewed to the right, then you can see that the area on the left, right, and the area on the right, the white area on the left and the white area on the right is not the same size. Okay, this is because because you don't enforce the rule, right? And you are enforcing that is actually it should be a HDR. Okay, so this means your your HDR and your credible interval are not the same because your gamma is a skewed distribution. Your HDR and your CI credible interval are only the same if your distribution is symmetric and unimodal, one mode and symmetric. Then only your credible interval is equal to your HDR. If not, then if it's skewed or is bimodal or whatever, then your credible interval will not be equal to your HDR. Okay, right. So any question, class, about this? Class? Any question?